Very good morning, everybody. Today, our topic going to be Ethernet. I want to uh, move a next step. Till now, we have done many training program in CAN. Moving forward, we want to explore the another bus system and another trending bus system called Ethernet. So usually as we do before, like we are going to start from the basics. Right now we are going to learn the basics of Ethernet first. From here we are going to explore that one, how the Ethernet can be used in automotive and all those stuff. Our focus is on automotive Ethernet, but before doing it, let us learn the basics of Ethernet first, and then we will come back to that. Okay. So the agenda for this session is exploring the Ethernet in detail. That is what our agenda. We are going to study how Ethernet works, and then what is its frame structure, etc. All those details in this session. As far as the Ethernet is concerned, it was developed at Xerox PARC between 1973 and 1974. This Xerox PARC is a private entity, and they initially invented this one. Okay, no. Then it was the commercially introduced in 1980. Then it has been becoming a open standard, and it was the IEEE take the ownership to standardize that. Right now the IEEE, it is aligned under 802.3 in the 802.3 series. So it is a network standard and available and standardized by the IEEE. Okay, no? It was commercially introduced in 1980, then it and was standardized by IEEE in 1983. Ethernet is also an asynchronous serial bus. I believe those who attended my the CAN sessions in the past, in that we spoke about asynchronous serial bus. The CAN is also a asynchronous serial bus. What does mean by asynchronous? Asynchronous means we have to understand, we have to know the opposite of that one, synchronous. The synchronous, to understand asynchronous, it is easy to understanding it by understanding its opponent right now. So the synchronous is the one, it need the clock pulse, otherwise clock source, to exchange the information. If you take the I square C, in the high, when the clock pulse is high, they transmit a bit, and when there is when the clock pulse is low, the receiver receive a bit. So in that way, that synchronous communication is working. So it always need a clock to perform the exchange of information, to clock to exchange the bits in the network. Okay, no? That is not the case in case of asynchronous. You don't need a clock pulse. Instead, you additionally need some sort of what you say, I used to call them as handshake signal. They are additional to your data. You will also have some more signal like a start of frame and a preamble and the end of frame, and then those sort of things. Those are like an handshaking things that helps us to transport our data in the network right now. So the Ethernet is also an asynchronous. Then the most of the people, the many don't agree that Ethernet is a serial one. But in my view, I feel that in my view, as well as the many network expert agree that the Ethernet is a serial one. Reason behind that is the packets, the bits are transferred serially, and it follows it shift the bits are arranged serially, and they are transmitted in a single medium. So in based on those aspects, we call the Ethernet as a serial bus. Okay, no, that is the thing that we have to know about Ethernet with respect to this synchronous and asynchronous. Again, the Ethernet is also using differential bus. We also know the reason why we go for differential bus in CAN, because that is a very famous topic that we know in the CAN. Like the car is the one which used to move, and then there will be an environmental noise and the EMF noise. Those will influence the signal transporter. Okay, no, when you communicate, when you exchange information in the physical bus, right, no, those will be like a series of PWM pulses, right, no, which represent zeros and ones. But those PWM pulses are a physical signal, like they are like a voltage pulses, right, no. When that voltage pulse goes from the transmitter to receiver, or from one node to another node, there are many factors which can influence that signal. Because of that, your original signal can be disturbed. That's why this differential bus concept is implemented. In that, when they want to transmit a particular, for I assume this is what they want to transmit, they take the complement of that, the original, they take the original, and then they take the complement of that too. So both of them are transmitted in the two different lines. At the receiver end, they have like a comparator or receiver circuitry, which can which can compare and build a original signal from these two balanced from these two complementary signals, right, no. So they used to call as a balanced circuit or something like that, balanced bus. At the end, you will get original signal. So if you get a negative noise in your original one, and then positive noise in your original signal, which will be the negative in case of your complementary, the plus minus noise is equal to 0. In that concept it works. So when they carry signals in two different lines, the noise influence will affect both the line. So when we have a plus noise as well as a complementary noise, when we add them together, we will get 0. That means they cancel each other, right? That's how they are. That's why they are going for differential bus, to avoid the noise. Advantage of Ethernet. Ethernet is versatile. So the CAN was invented in 1980, but before that the Ethernet was there in the market. And the Ethernet is a very famous network standard used in PC communication. So it is if the PCs are dominating the world today, so everywhere you can see PC. So this Ethernet was nearly 50 years it is in the market, and there are numerous libraries developed. There are many new network products developed using Ethernet. Similar to the CAN, the Ethernet is also easy to use. You require a simple the twisted pair wire to perform the communication. So every PC hardware used to have the port for Ethernet. So that's why they call that as easy to use. Wide selection of product is available. You have different variants to choose in the Ethernet, like 100 Mbps and then gigabits per second Ethernet. Like that, we have different variants. You can pick whichever that you want. It's fast. That means the capability of CAN is only 1 Mbps per second. But today, in the connected world, the people want to see the maps in their car dashboard, and then they want to attend a call over there. They want to they want to see the infotainment information over there. They want to place some sort of the camera, front ADAS camera output over there. So today the bandwidth, we need high bandwidth, because we need that much, we have that much of advanced feature. In those cases, the CAN is not CAN has a limitation. It can only its bandwidth is up to 1 Mbps per second. You cannot go beyond that. When it comes to, even we have another option like which one, like the CAN FD, even you can go in that up to 5 Mbps. But when it comes to Ethernet, you can go in terms of gigabits per second. So it's very high bit rate, so that you can exchange very complex informations or very high data payloads with high speed. It can span long distance. The CAN bus can have maximum of 40-meter length, but beyond that, they have a limitation. They cannot go beyond that one. So when it comes to Ethernet, you can go in terms of kilometers, or it can support very long distance without any problem. So that is an advantage of Ethernet. Interfaces are electrically isolated. When you choose the fiber optic cable as your physical medium, then you are free from EMF noise or induction noise. Everything is, you are isolated, so that you are protected from those environmental noise when it comes to when you use those sort of things. Ethernet support that one. The cost is reasonable compared to other network standard that is available in the market. Ethernet is cheap. Because most of the when it comes to software, most of the libraries are already written over a period of time, so we have many ready-made packages. Because of that, the implementing Ethernet and the cost of implementing Ethernet is very less compared to other network standard. When it comes to any network standard, it has a network, the IEEE standard document. The document that describes Ethernet is IEEE 802.3. Ethernet standard is one of the several 802 series standard that defines alternate approaches for network physical layer and method of media access control, which defines how computers share network. The physical layer described in the standard includes the electrical specification of transceivers and then electrical and physical specification of connectors and cables. Those details are given there. The media access control include how each computer knows when it can transmit and how the computers identify intended receiver of transmissions. So those things are covered in the media access control.